Newton's second law of motion with the application of the differential equations.
Yo, pahibogay. Pero na nato dito ito classroom ako basta sumam. Wait! Alin na!
Good morning, everyone. So today we will have a new topic, which is applications of differential equations, specifically the Newton's second law of motion. So everybody, please pay attention, okay? So everyone, this is the Newton's second law of motion, which states that the summation of forces is equal to mass times the acceleration, where F is the resistive force, M is the mass of the object, G is the acceleration due to gravity. So everyone, we know the land? Yes, ma'am. Agad mo the land? Yes, ma'am. Okay, so I'll send you a link later para mas masalihan natin yung ano topic. And next week we will have at least, is that okay with you guys? Yes, ma'am. Okay, let's Yes, ma'am. Okay, ma'am. Tungit na! Yung kakumin na sa ikwansi. Kaklaw ka ninyo. Nawala mo na. Sige, punta ay. Tigwinta.
Unsa naman na oy, wala naman mo kasagang. Mga wait naman kayo mo. Bantay ha, mo serve na ko. Giro bay. Ay, ano.
Bay, oy, okay ra ka bay? Okay ra bay? Atay limbong na kayo ilang. Lagi, klaro kayo. Tinatiran ko lang, limbong na kayo. Tinamot pa dyan. Bawi ta bay. Bawi ta sila. Meron naman iring. Bay, kuhan ko sa mama bay. Balik lang pa dito. Sige bay, kita lang tayo niya. Sige, bye-bye. Thank you sa pagpapamila. Oh, magkakit mo na yung dito yung day. Bay, bay. Tulong sa mga nila. Bay, wala na po. Sama sila po ibay. Ito sa mga. Kaya ito po ang bayan.
Good day, everyone. I am Mary Grace P. PLATERO, and today I'll be going to discuss to you Newton's second law of motion in the application of differential equation. So let's get started. Newton's second law of motion. It states that the sum of forces acting upon an object is equal to the product of mass and acceleration. Its general formula is F plus m multiplied by the change of velocity with respect to time is equal to mg, where F is the resistive force, m is the mass of the object, g is the acceleration due to gravity. Why is Newton's second law of motion important? Newton's second law of motion is very important because it shows the relationship between forces and motion. It allows you to calculate the acceleration and therefore velocity and displacement of an object with known forces. This is incredibly valuable for scientists, engineers, inventors, etc. Let's have some examples. Number 1. A box of mass 4 kg falls from the building whose resisting force is numerically equal to 0.003 v, where v is the velocity at any time t. A. What is the velocity of the box at any time t? B. What is the velocity after 5 seconds? Let's solve for letter A. So, we have our formula. Resistive force plus the mass multiplied by the change of velocity with respect to time is equal to mass multiplied by gravity. So, our resistive force is equal to 0.003 v plus the mass, which is 4 kilograms multiplied by the change of velocity with respect to time, is equal to 4 multiplied by 9.81 meter per second. To simplify our equation, let's multiply 1/4 to the both sides of equation. So we'll get the change of velocity with respect to time, or dv over dt, plus 0.0075 v is equal to 9.81. As what you can observe, our equation is linear to v, which means that it can be solved using the first order dE. And the solution for our first order dE, linear dE, is v multiplied by the integrating factor phi is equal to the integral of function qt dt multiplied by the integrating factor phi. So, where phi is equal to e raised to the integral of function pt dt. So, solving for our integrating factor phi is equal to e raised to the integral of 0.0075 dt. Let's integrate this. We'll get phi is equal to e raised to 0.0075 t. Now that we've already solved for the value of our integrating factor phi, let's substitute it to our equation. V multiplied by e raised to 0.0075 t is equal to the integral of 9.81 multiplied by e raised to 0.0075 t dt. So, we've got v multiplied by e raised to 0.0075 t is equal to the integral of 9.81 raised to multiplied by e raised to 0.0075t dt is 9.81 over 0.0075 multiplied by e raised to 0.0075 plus c. V multiplied by e raised to 0.0075t is equal to 13080 multiplied by e raised to 0.0075t plus c. Let's multiply 1 over e raised to 0.0075t to the both sides of the equation. We'll get v is equal to 13080 plus c over e raised to 0.0075t. Now, we have already solved for the equation of our velocity at any time t. What we're going to do now is to solve for the value of c. Given the conditions earlier that the box is at rest, we can assume that t is equal to 0 and v is equal to 0. So, let's substitute these values to our equation. We'll get 0 is equal to 13080 plus c over e raised to 0. And any integer raised to 0 is equal to 1. So we'll have 0 is equal to 13080 plus c. Now, we have our value of c, which is equal to negative 13080. Let's substitute the value of c in the equation for the velocity of the box at any time t. We'll get v is equal to 13080 minus 13080 multiplied by e raised to negative 0.0075t. And this is our final answer for the letter A. Let's solve for B. What is the velocity of the box after 5 seconds given after 5 seconds? Given from the equation that we have solved earlier, let's substitute the value of t. So v is equal to 13080 minus 13080 multiplied by e raised to negative 0.0075. So our t is equal to 5. So let's substitute this one and we'll get our velocity after 5 seconds is equal to 48.96 meter per second. Example number 2. A ball of mass of 2 kg is dropped from rest in a viscous fluid, the resistance of which is 0.001 v Newton, where v is the instantaneous velocity in meter per second. What is the velocity of the ball after 4 seconds? Let's solve for the velocity at any time t. So, the resistive force is equal to 0.001 v plus the mass, which is 2, multiplied by dv over dt is equal to 2 multiplied by 9.81. Let's simplify the equation by multiplying 1/2 to the both sides of the equation. We'll get 0.001 over 2v plus dv over dt is equal to 9.81. We can observe that our equation is linear to v, so we can still use the solution for the first order linear dE, which is v multiplied by the integrating factor phi is equal to the integral of phi multiplied by the function t dt. dv over dt plus function pt is equal to qt is the general form for the first order linear dE. So, let's arrange our equation for us to simply identify are function pt and function qt. So dv over dt plus 1 over 2000v is equal to 9.81. So our pt is equal to 1 over 2000 and our qt is equal to 9.81. Let's now solve for our integrating factor phi. Phi is equal to e raised to the integral of function pt dt. Phi is equal to e raised to the integral of 1 over 2000 dt. Phi is equal to t over 2000. Now that we have already solved for the value of our integrating factor, we can substitute it to our equation. V multiplied by e raised to t over 2000 is equal to the integral of e raised to t over 2000 multiplied by 9.81 dt. To simplify the equation, we multiply 1 over e raised to t over 2000 to the both sides of our equation. We'll get v is equal to 196.20 plus c over e raised to t over 2000. Solving for the value of c at t is equal to 0 and v is equal to 0, we have 0 is equal to 196.20 plus c over e raised to 0. 0 is equal to 19620 plus c. So our c is equal to negative 19620. Let's substitute the value of our c. We'll get v is equal to 19620 minus 19620 multiplied by e raised to negative t over 2000. And this is the velocity of the ball at any time t. Solving for the velocity of the ball after 4 seconds. Using the equation we have solved earlier, let's substitute the value of t. So v is equal to 19620 minus 19620 multiplied by e raised to negative 4 over 2000. So the velocity of the ball after 4 seconds is equal to 39.2 meter per second.
Boy, baru na magsama sila pagpili. Pagpili na din yung mas na pula. Pili na ako, kaya nila ako sila. Pili na naman sila ako. Pili na naman sila. So na! Bantay mo ba eh? Pili din ninyo eh. Pili na eh. Kaya?
Yung something, yung pagdaog mo, mga weak man mo.
Ngayon ka, amray gamitan dito bilang location. Para na naman tayo mahal yung minong ko sa pagkakusul. Pero pili na sa may kumpetensya ba? Tara.
Tara.